So next thing that we're going to get onto is strings and loops, and this one is actually very similar. There are lots of things that are the same because they're sequences, but we also have a few extra little bits and pieces. So I just wanted to talk about some of the string operations, the ones that we use quite a lot, like strip, replace, join, and split, are very handy. And just as a recap, we have done these once. I'll show you how they work. So some new stuff. So let's say we've got A equals some text, and we've got a space on the end of it. That's really annoying, right? Because that space is going to be there. Worse still is when we have a new line on the end, and so you try and do the see, I only talked about Python 2.7 before. You do a print, and then all of a sudden you've got that extra new line on the end. So you've got this breaking of stuff. And so what we'd use for this is strip. Okay, so a.strip gives you the same string, but with the white space removed from either side. White spaces, new line characters, spaces, and tabs. All right, so it gets rid of those things. That's the first one. Replace, which you should be very interested in at the moment. So let's say we've got A is equal to cat on mat. This is a bad cat that sits on a non-cat mat. All right. Replace takes two things. The first thing is the thing that we want to replace. In fact, let me just show you the help so you can see. Help a.replace. You can always look these things up, old and new, and it has an optional count. If count is there, then it replaces that many of them, or up to that many. Without it, it doesn't. So old and new. So a.replace cat with venomous spider. The venomous spider sat on the mat. It is a bad venomous spider that sits on a non-venomous spider mat. Okay, so we've replaced all of those instances. Dead simple. Right? We could do the same thing with cat. We could take the mat part out.
Can you do multiple replacements with one call, James?
No.
I didn't think you could either.
No. There we go. The cat sat on the chair. It's a bad cat that sits on a non-cat chair. If you wanted to do multiple, you can chain them, because what comes out is a string, so you can say there we get the Velociraptor sat on the first year student. It is a bad Velociraptor that sits on a non-Velociraptor first year student. Okay, so you can see how to replace these things. You can do them all in one line if you want to. If you had multiples, right, and you wanted to be really neat with it, but okay, let me just apropos nothing at all, and not because the coursework requires any of these things. Big hint again. You've only got a handful of things that need replacing, and it's fairly fixed. I'm not really going to be that upset if you just do replace 5 times, okay? But when it comes to elegance and things like that, it would be quite nice if you had some way to have a list of things that need replacing and then process them. So let's have a go at that while we're here, okay? Let's just give that kind of thing a go. So I'm going to just make a new thing, which I'll call placer.py. Right, so I'm going to make a function which takes something as input and replaces it with based on a list. So I'm going to say takes in some text and it needs some replacements. So what I'm going to do is I expect to call it like this. Let's just put a pass in there for now, and I expect to call it like this: print replacer sat on mat, and I want to replace, and I'm going to give it a list of things, right? So in that list, I'm going to give it, I'm going to use use tuples. Remember we talked about tuples. I like lists that you can't edit. I'm using them here mostly not because of the non-editing, but because it's nice to actually see different brackets, so you can actually see where one ends. I could have done it in lists within lists, but you know, lots of square brackets together and no real benefit. So cat is going to be replaced by go on, badger. Right, it's going to be replaced by badger. Oops. So that's one tuple of 2 items, you see. And the next tuple of 2 items is going to be mat, and that's going to be replaced by mushroom. And I'm going to replace also sat with so here's our call, and that looks a bit complicated to me, so I'm just going to pull these things out. So our actual base string, if you like, is going to be this. The list of replacements, called reps here, is equal to this. And that's fine too. So here I've just split them out because I decided that one line, although it does the same thing, wasn't easy to read, and it's better to have 3 lines that are easy to read and edit than 1 line which is combining everything into one place. The other thing you can do is you can put some of these things on multiple lines because it's got a comma on the end. We can see them like that, and we can actually see how these things fit together. So now we know what kind of data we expect, we can look at what we need to do. The text is a string, we don't need to iterate over that part, but we are going to iterate over replacements like we did before. I'm going to say for R in replacements. So R will be firstly cat badger, then mat mushroom, then sat stood. Okay, so it's a tuple of 2 things. They're just like lists, except you can't change the items, remember. So if I say R0, that's going to be cat, then the next time around to be mat, the next time around to be sat, and R1 will be badger, then the next time around to be mushroom, the next time around to be stood. So what I want to do is say that text is equal to text.replace R0 with R1. Okay. Once that's all done, we just return the text. Okay, so each time it goes round, it replaces what text refers to with a version of the string that has a replacement. Remember, strings are immutable, just like tuples. So we can't just replace it in the string that we're given. We have to actually make a new one, and we're sort of overwriting the place it was stored or referred to, not actually changing the original string. The original string is never going to change, but what we return out is going to be the last version that we made out of it, right? So each time we do text equals text.replace, we are making a new version and referring to that one instead. Okay, let's see what this does. Code, and I missed a bracket, so that didn't help, right? Because we've got an open bracket there, and then I missed a closed bracket. The badger stood on the mushroom. Okay, brilliant. All worked out fine. So we talked about, can we do more than one at once? No, but now we can because we've made our own. Okay, so that's kind of handy. Ridiculously handy for the coursework, in fact. Big massive. Okay, split and join. You've seen split. We've done that already today a few times, but just to be clear, you could do this like that. Okay, so let's store that into A. A.split based on the slash gives us those 3 chunks. If we've got some text like we did before, so we had text. Here we go. So let's still around text. Text.split, you saw it on space, not splot, that's not a thing. On space. There you go. Gives you the thing divided up into chunks based on spaces, so pulls out the words. Join is really handy. It does stuff the opposite way around. So if we've got, I can't remember what we got around. S, not that one. I think I overwrote A. Okay, so let's say A equals range 100. And we'll shuffle it. Every time. Make a list. There we go. We've got a randomized list, so a shuffled list. We might want to actually join those things together into something to print out. So maybe we put the slashes in between or something. So we can do a /.join, so the string, and then join whatever we want. Oh, actually they're not into their numbers, so that was a really bad idea. I'll tell you what, we'll go with S. That'd be easier. I was just about to get the sledgehammer out, but there we go. We've effectively replaced all of those spaces with slashes, but we can do join S up to the first 10 characters and all kinds of stuff. Okay, so it gives us a really flexible way to work with those things. We can iterate through strings. So you've seen us iterate through lists. We can also iterate through strings, which is quite handy. So let's say there. We can also do for I in text. We get each character. So a string appears like a sequence of things. So we can go through each character in turn, which can be quite handy. Common patterns for this stuff. So firstly, tidying and normalizing, stripping, replacing characters you've seen. You might use this for sanitizing paths a little bit. I would suggest if you're doing anything that accepts stuff from the outside world, look for libraries that will do the sanitization for you, because they will have been thoroughly tested and done. Only do your own if you're doing something a little bit different, right? So like if you were writing in PHP, don't try and write your own way to check if anyone's putting any bad characters in. There are libraries and functions that can do it for you. You'll find that stuff in Python as well. But let's say you're going to open a file, right? And you want to check to make sure that it's not got a path in it that's bad. What you might do is go, well, let's say file name is equal to something, and it might be ets shadow, right? Now, clearly, we don't want people opening that file. So if we're given that as an input and we're going to open a file, we probably want to check that it's not got some certain keywords in. We might say, let's not have anything that has ets in it. Okay, so we can use that. So you might say, if etc in file name. Well, we can actually just put etc in file name to see. Oh, can you spell it right? Third time lucky. To see that's true. We can check, say, something that we know isn't in there. That says false. Shadow is in there, so we can do that. We also might be in a situation where we've got things like file name equals ets shadow space, okay, like this. And it's really annoying because if you try and add something onto the end of it, you've got an extra space. That's where we'd use strip. So if you were doing stuff with file names as well, by the way, one of the things that you could potentially do is use things like ... to go backwards into different places, or other ways to get there. So you maybe look for stuff like this. Make sure you can't go backwards. So that's quite a common thing. You maybe replace characters in there, sanitize paths and stuff. The other one is parsing through stuff. So splitting something, iterating over it. It's actually a really big area of computer science, which you're not going to get into particularly deeply, at least not this year. But this sort of basic version of it is really handy. And as an example, I thought what we could do is build up a program that can go through a shorthand for production and dispatch of stock. So let's call it prod.py. And we might have something like this. This is going to be our shorthand. So as you're working and you're making whatever it is you make with pottery items or machinery or anything, you just make a note of like, well, I've just done a 5, that's 5 to, just another 5, that's 5 to, just another 5. Someone's come and collected 3, that's -3, and that's the end of the day, slash. Then you move on to the next one. Really simple shorthand things. Let's parse it, right? So let's work out what we're doing with these things and produce a daily tally of like the comparison of input to output. So we might say something like tally equals this, and then we want to say display info tally, right? So find that function, display info, and it takes some sequence of stuff. So we might call this, I'm going to call it sec for now. Probably I would call it tally, but I do worry that whenever I put something in here called tally or whatever and use the same name here, then it makes it look like it has to be the same. It doesn't. It just sometimes makes sense that it is. Okay, so sometimes that's just the best name in both places. Sometimes someone calls it one thing and you want to refer to it in your code something else. It doesn't really matter. When it goes in, it's the same. It's the values in there that count, not the name of it. Okay. So what we're going to do is, first of all, we need to split this based on day. Okay, so if we're going to think about multiple days, let's split it based on that. So we can say days is equal to tally.split based on the slash. Okay, so each day is separated by a slash. So you move on to the next day. So then what we're going to do is we're going to display whatever we do now for each day. Well, do you know what? It would be much easier if I could just go for D in days, display daily for that. Yeah, we've got that function yet either. So def display daily. I'll call that thing day. And now I don't need to worry about slashes because I'm only going to get given the numbers and the commas for a given day. Okay, so I would now say that, well, the items in there is equal to day.split based on the comma. And then we can just have a count which starts off at 0. That pattern's there again. For I in items. Okay, now we're going to turn that into a number. So I is going to be each one of these things. So let's say I equals int I, or we'll call it value equals this. Count plus equals value. And then because this is all for displaying, we're not going to return the values, we're actually going to print them out. Daily stock change is, and I'm just going to put the count on here. So what's going to happen? This string will go into this function to here, so it goes whoop, and up to here. We then split it based on that slash, so we get 2 pieces. One's got 5, 5, 5, 5, 5, minus 3, 2. The other one's got 1, 1, minus 2, 3, 3, 4. For each of those, so that's 2 pieces, it then calls display daily. So this happens firstly with this part, and it goes through each item split by the comma, turns it into an integer, so it's going to be 5, 5, 5, minus 3, and 2. Okay, because remember they're strings to start with, and then we just add count that value. So what we should see is that on this first day we should have what, 15 minus 3 plus 2. Okay, so that's going to be 14, and then we're going to have 1, 1 minus 2, then 3 and 4. So that's going to be, well, that first lot cancels out, so that should be 7. Yeah, so that's our relative thing. In fact, let's add another day where we should end up with a negative number. So let's say on this day we didn't produce a lot, maybe we produced like the odd thing, but we're going to sell 1, produce 2, sell 4. Right, let's see how that goes. Okay, so there you go. Over here you can see 14, 7, the minus 3. And what that does is it shows you what the change to the stock is over the day, because first day you made 5, then you came back and made another 5, 3 got taken away, dispatched somewhere, and you made another 2, gives you a total of 14. Made 1, this is the next day, made 1, got rid of 2, made 3, made 4, gives gives you the 7, and this one -2, 2 -4 gives you -3. Okay, so this is a fairly common use of things like split, and particularly with loops, and you can see how I've divided up this problem as well to make it much easier for me to answer. Right, so we talked before about things like functional decomposition briefly, but haven't really had a chance to see it, played out in multiple layers. There it is, right? I started at the bottom and said, right, I'll display the info. Right, how do I do the first step? And then for each of those things, well, it's easy for me to call out. I could have put all of this code inside here, inside the loop, would still work, but it would have been a lot more annoying for me to have to write it, because I've got to remember, well, this is inside the loop, what's there. Here, I can forget the loops. All I've got to do is think about what I do with one thing. And if I need a loop to do that, well, I can make my own loop and work in that side of that function. The breakout here is create a program that asks the user to enter some text. The text will be displayed back to the user, but when a plus character appears, the text following it will be made uppercase. When a minus character appears, the text that follows will turn to lowercase, and the hash character stores the text being printed as originally given. Okay, so the text Alice, Bob, and then you've got a plus, and Claire took minus Dave's socks, and plus gave them to hash to Edith. Comes out as Alice, Bob, and Claire took Dave's socks and gave them to Edith. Okay, so how are we going to go about this? I'm going to give you a little bit of a template before we go. So I'm going to put that. Actually, maybe put it in here, and I can actually push it directly up, and you can come back to it. So in source Python source. This one works. So what I want you to do is you're going to have the if name equal to main, and in here you're going to go, let's call it process text, and we will take the Alice and Bob bit because that's a good test. We'd expect the output to be as up here. Okay, so we can see what that is. So we need to create the process text function. We'll call this the input text. I think that makes sense. And inside there, you're going to go through and display each character. But when you see certain ones, you will change your default display. It's either going to be making everything uppercase or making everything lowercase, or it's going to be just doing things as normal. Okay. So the way I would go about this is I would have a couple of booleans. So I'd say upper is equal to false, and lower is equal to false. And then as I display each character, if upper is true, I make it uppercase, and if lower is true, I make it lowercase. And ideally you want to be in a situation where you have both, but we won't talk about tri-state logic at the moment. If they're both false, then you just print it as it is. Okay, so we would do something like for C in text, and then we have our algorithm, right? So is it a plus? If so, set upper to true, lower to false. Is it a minus? If so, do the opposite. Is it hash? If so, set both to false. Okay. Otherwise, it's if, elif. Remember these things. So we would have each of these checks, and then at the end we'd have an otherwise. So you'd have something like, do you know what? You'd say something like if C is equal to this, do some stuff. I'll put pass in there for now. Elif C is equal to this, do some stuff. Elif blah blah blah, and then the last one could be otherwise else. Okay, or the other way to do it is you have your if, you do your code, so whatever your code is, and then you do continue, right? Because you don't need to print this character out. So you go, just move on to the next one. Okay, so you should remember that from the loop section. Right. Otherwise, so if you haven't done these, uppercase, that's not meant to be actual code. It almost was though. If uppercase is true, uppercase letter, lower is true, lowercase of the current letter, otherwise print the letter as is. Okay, now I say print the letter, and that's a bit of an annoying thing because really we want to do what we did before and add it to a string, right? Because otherwise we're going to have to say print, and then if we want to go to the next line, then we have to say, well, don't do that, so end equals nothing. That gets really, really annoying. So what we're going to do is we're going to say output is equal to an empty string. And then we'll just add to that. So we'd say output equals output plus the uppercase of the current letter. Is, and then here we're going to say return. So that would be my way of doing this. Okay. I'm going to convert that to HTML. I haven't got any code in there. Right. So I'm going to push this up to the site. So when you refresh, you'll see any second now. Oh. There we go. So there's the solution to the first one. That's up there, and you've got the outline at the moment for what I would do with this one. So that's their next breakout session. We just Windows back. There we go. So I said we would take 20 minutes. I think that's probably about right. So let's say, sorry, let's say 25 past. Okay, I think it's probably good to quickly go over what I would say is a solution. I'm going to generate it on the spot for that challenge, and again, we'll put that back into the notes, so you can always go back and refer to the bits and bobs that we did and look at some model answers. I'm going to share screen. This is what I said would be a reasonable thing to put out, and so we've got our output, we've got the stuff there, and then for each character in the text, we look and see what it is. So I'm going to say if the character is equal to a plus, then I'm going to say upper equals true, lower equals false, and then I'm going to say, right, now just continue, right? Because there's no point going through the rest of this loop. Just move on to the next bit of the loop, the next iteration, because we know it's that. It can't be anything else. There's only one character in there, right? So that's fine. If the character is equal to a minus, then we want basically the same thing but flipped. And last bit is again almost the same, but this time if the character is equal to a hash, then both of these things should be false. Now at this point, inside the loop. We haven't jumped back to the start of the loop to carry on with the next iteration. We know that it's not plus, minus, or hash because they've been dealt with, right? If it was one of those, it would have gone into its if statement, and then it would have hit the continue, and then it would have just gone, right, skip the rest of the loop, let's move on to the next turn. So all we need to do is either make it uppercase or lowercase or do nothing. So we can say if upper out plus equals current character C dot upper, and if lower out plus equals C dot lower, else out plus equals the character. I've just realised that I didn't call it out, I called it output. So let's go fix that. Output, yeah, output, and output. I'm also going to tell this that it's printed, so I call it done. Done is that. Print. Done. Okay, let's see what we get. So what we can see is here, Alice, Bob, and Claire in capitals took. Then it goes to lowercase. So even though Dave had a capital D in the input, you can see is now lowercase, lowercase, lowercase. Gave them, and then to Edith, which stays in the same case. So we have all of those things that we need it to do, and they're in there. And it wasn't a particularly difficult thing to do. Let me just go back to looking at inside a nicer view. It wasn't a particularly difficult thing to do. We just had to follow the algorithm. So we put the notes that were there and give it a go.